the last official lesson for Chapter 7. Today is going to be a couple more topics we'll talk about, and the good news is you have the rest of the week up into Friday to kind of practice and perfect what's going on. Yesterday I introduced you to the general shape of the exponential graph. I explained the importance of understanding whether it's growth or decay. Remember, it is growth if you look at the base and it's bigger than 1, because remember the 1 represents 100%, and it is decay if the number in the base is smaller than 1. I then explained the two general shapes that you should know by today's lesson, and what I said, because everything does go left to right, is that exponential growth is an airplane taking off. I said that it does not touch the x-axis, and so therefore whenever you graph that, it just kind of goes close to the axis. And remember, like an asymptote is what you call it, it never touches, but that is the general graph. Exponential decay would be like an airplane landing. Again, what happens is, this case, again going left to right, it's going down, so it comes down and then continually approaches the graph that way. So those are the two shapes that you should have come in with at least an idea of what's going on. Today what we're going to do is use our common sense and apply it to some higher level graphs to pick a proper answer from a multiple choice question. Although you won't be looking at multiple choice questions until the quiz, you should be able to sketch just a general shape after the first part of this lesson is complete. So let's just go ahead and get to the graphing part real fast. From what I saw yesterday, I think some of you were trying to figure out how to graph these things in your graphing calculator, but just thinking about it, as long as you understand the general shape, you won't need to actually graph them in your graphing calculator. Again, you just want to understand what the general shape is, and so that's what we're going to do right here. I'm going to graph them myself, going to the y equals button and typing in the first function, 3 to the x. And again, this is a growth function because that's bigger than 1, and we should see an airplane taking off, which is what we see. The question is, what happens if we put a negative in front of that 3? And so we're going to go ahead and move down 1 and put negative 3 caret x and see what happens. And what you notice is it took this graph and simply turned it into that graph. Alright, so let's see something else real fast just to make sure. So I'm going to delete both of those, and then I'm going to graph 2 times 0.7 to the x, which, because that is my base, it should be decay because my base is smaller than 1. Let's see if it's actually decay. It should be coming down, which it is. And so let's see what happens if we graph one with a negative in front. So moving back to here, negative 2 times 0.7 caret x, and graph it. And notice what happened was it took the original graph, which looked like this, and it turned it into this. So what we notice, or what we should notice, is that the negative sign just flips it upside down. So again, the original graph was an airplane taking off in this one because it was growth, and then it just flipped it on the other side of that x-axis as if it was a reflection of it, which is what you actually call it, and it turned it to go down. The second graph initially was decay, which was going this way, and then again it flipped it over that x-axis and just simply turned it the other way. So because of that, we can combine our understanding of the graph to sketch a cheap version of any exponential function. So some real quick examples. Again, you don't want to use your graphing calculator for this because otherwise you are losing out on the thinking part of it. So here's the thing. First off, what you want to do is look and ask yourself, is this growth or decay? That is bigger than 1, which makes it growth. And because it's growth and there's nothing going on, we understand that the natural growth function looks something like this, and so your cheap sketch would be a graph that looks something like this. And that would be all you have to do today. I don't need numbers, I don't need points, I just need for you to sketch what the graph should look like. And again, you might make some mistakes on the worksheet I give you after this, but just make sure that you again understand that making mistakes now is fine. You just want to get them out of the way before the quiz comes up. Looking at B, this is not the base. The 0.63 is the base because that's what's got the exponent attached to it, and this is decay. Because I know it's decay, I know that decay is shaped something like this, and because there is no negative sign to flip it over, it means that it is going to look something like this in terms of its graph. And again, I don't need anything perfect. I just have to figure out what the curve is going to look like, and then with that known, I should be able to pick it from a multiple choice option. When you look at C though, the base here is a fraction, and again, if you don't know whether it's bigger than 1, just do the division. 2 divided by 3 gives me the answer 0.66, so that means that this is also decay. But what you notice about this is that there is a negative, and remember what happens on a negative is it flips it over to look something like this. So this graph is actually not going to start up here, it's going to be the reflection of that graph, and it's going to look something like that. That is what the negative does. Again, the negative takes the decay graph and just flips it upside down and puts it on the other side of the x-axis. So again, this would be the negative portion of x, so you could see that. That would be the positive the negative portion of y. This is the positive portion of y, and the way you can imagine that is that the negative sign simply puts the graph into the negative portion of y. Same thing here. This is growth. Because of that 3, that's your base, and so we know that growth is an airplane taking off, which means it has that shape. But when we look at the very front, we see a negative, so again, what this does is it takes that growth function and it flips it upside down, and so we know that this graph should look something like that. It should be a reflected growth graph, which means, again, if the initial one took off here, it should be ending up down there. So those 4 things are what you probably want to try to get into your notes to make sure you understand what's going on. But again, as you go to that sheet, make sure you just try your best to answer them. You're not going to lose points for messing up on that sheet when you get it, but if you don't at least try it with no assistance, then you won't know if you really understand it or if the calculator is just giving you answers, and you don't want to take too long on answering those questions because they're really not that bad. Notice that our first level of the problem is, again, recognizing whether it's growth or decay. That's when you look at the base number. Our second level is remembering the initial shape, which is where we either drew this or this. And our third level is flipping the graph if necessary. So again, knowing how to flip the graph if you have to. The first 2 levels, again, should have been under control yesterday, and the third one is not really so difficult to apply. Again, just be sure to take the work seriously today so you can practice your craft. The second thing we're going to talk about today is the growth and decay formula. Anytime something is growing or decaying by the same amount over a period of time, we have the option to use an exponential growth or decay formula. Write these down for your notes, but again, you must memorize these for your test. The growth formula is A equals P, parentheses, 1 plus R over N to the power of NT. This is the general formula, and it is just applied differently depending on if it's growth or decay. You notice that the growth formula has a plus in the formula, and the decay formula has a minus, so you don't really need to remember both of them. Just try to remember this one, and what will happen is that way if you know it's growth, you know to put a plus, and you know that if it's if it's decay, that you know to put a minus. Now, in terms of the letters, after you've written that down, P represents the principal, or what we call the starting amount. So if we started out with 1,000 people in a building, P would be 1,000. If we started out by investing $1 million, then P would be $1 million. If we started out by saying there are 27 animals in the forest, then P would be 27. R is your interest rate. Again, that's usually a percentage number that you have to convert by moving the decimal 2 spots. T represents the number of years that we're talking about, and the tricky number is N. N represents the number of times interest is compounded. If it says that the interest is compounded annually, then that means that you're only going to do it once at the end of every year. So in that case, N is 1 because every year is only going to be compounded once. Biannually means it's going to be twice a year, so you would have N equal to 2. Quarterly, just like in a sport where there are quarters, it breaks it into 4 sections. So quarterly means that you're going to have N equal to 4. Monthly, of course, that means you're going to do it 12 times over the course of a year. And daily means that you're going to do that change, or you're going to compound it 365 times a year. So you don't really need to write those words. As much as any word that you don't understand, you might want to write down. But again, the main thing is if you see any of these words, you got to understand that they apply to N, and that you have to figure out what N is. Again, annual, biannual, which is 2 times a year, quarterly is 4 times a year, monthly being 12 times a year, and daily being 365 times a year. If you're talking about annual interest, then what happens is when you have your 1 plus something, R over 1, pretty much R over 1 is just R, which is why you can just write it as 1 plus r. Also, if you have 1 times t, that is just t. And so if you have annual interest, which is what most of them are, what you will do is just pretty much just use the basic version of it, which looks like this. Again, this is just a simplified version of the original, but the difference is if n is equal to 1, then dividing by 1 just gives us r, and multiplying by 1 just gives us t. But if you just memorize this one here, that should at least give you your base for everything you need to know there. Alright. Again, practice is the best way to learn this material, so let's just look at a couple examples and go on to whatever we're here to do. First question says, suppose you buy an item online for $7,000. Based on the current trends, the item is expected to decrease in value by 5% each year. What will the value of the item be after 7 years? Again, first thing I want to do is write the formula. So A is equal to P, parentheses, 1 plus R over N to the NT. P in this case is your principal in terms of what you started with, and you are looking at 7,000. Actually, I think I messed up there because I put a plus and it says that the value is going to decrease, so it actually should be minus R over N to the NT. But again, P in this case is 7,000. 1 minus your percentage in this case is 5%. Well, 5%, if you move that 2 spots, is 0.05. I'm sorry, that's not your fraction. Over the number of times it's going to happen. It says it decreases 5% each year. That means it is going to do that 1 time because it only does that every year, which is 1 time. And that means that 1 times t, you want the number of years afterwards, which would be your 7 years. That means you end up with 7,000, parentheses 1 minus 0.05, because that's what that divided by 1 is, to the 7th power. Again, notice that is when I told you that if you ever have annual changes, that it's going to look the same as that. Notice that that is your formula. 1, except it's this one, 1 minus r to the power of t. So again, as long as that n is equal to 1, what happens is those numbers just kind of change into a nice format, and all you have to do from there is type them in. So we type our 7,000, parentheses, 1 minus 0.05, caret 7, and we get the answer of $4,888. I'm sorry, $4,888.36. Again, once you get here, all you have to do is just type in whatever you got in that formula, and you should be good to go. Okay. So again, the main thing on that is knowing that your starting number goes in for P. The number of times, which would be your your rate, which is your percentage, has to be converted. Your number of times is based off of whatever they tell you there, so that was equal to 1, and that the number of years is your T. As long as you practice that this week, you should be good by Friday. Now again, I don't expect for you to start out the day being perfect at it, but with the homework being there, with the fact that you can redo and practice and redo again and practice, I think by the end of the week you should be okay with that. Second question says, suppose you invest $300 into an account that earns 3.1% interest compounded quarterly. How much will be in your account after 6 years? Again, we're talking interest, and interest is usually a good thing. So it's P, parentheses 1 plus R over N to the NT. So we're going to fill in what we have here. Again, 300 is what I deposited. That's my starting amount. 1 plus my rate is 3.1%. But again, if I move that 2 spots, it's 0.031 over, it says it's compounded quarterly. Again, quarterly, if you think sports quarter, there are 4 quarters in a game or 4 quarters in a dollar. That means that n is equal to 4. And then 4 goes up here times the number of years, which is 6. In other words, you're going to do this for 6 years, and it compounds 4 times each year, which then gives you a number there that you can use. What I am going to do is go ahead and change that number. So 300 times 1 plus, and I'm going to put 0.031 divided by 4, which is 0.00775. And I'm going to turn that number into an actual number, and then I'm going to type it in from there. So I'll clear this so it's visible. 300 parentheses 1 plus 0.00775 caret 24, and it says it will be worth $361.07. Now, if you are a good calculator programmer, you can probably do it from here. Just be careful again to remember that, actually I think the order of operations would take care of itself. So let's see, 300 parentheses 1 plus 0.0031 divided by 4, close, caret, and I would probably still not put 4 times 6, but I would put my 24 here, and that does not work. Why not? What do I do differently? 300, 1 plus 0.00, I put 0031, sorry. So 300 parentheses 1 plus 0.031 divided by 4, because it should work with the order of operations, caret 24, and yet you do get your 361.07. So I guess you can type it in that way, which makes it a little bit easier. Again, I would just suggest not typing in this as your power, but actually turn that into a 24 so you can actually type it in correctly. Alright. Before moving on to MathXL, do me a favor, come up and get the worksheet that I have for you. It looks like this. It's got some questions on it where all you're going to do is say, y equals whatever is going to look like whatever your graph is, whether it's this graph, that graph, or this graph. And so your job is to fill that out, bring it up to me, and then go to the MathXL afterwards. Again, do not go to MathXL until after you have gotten this sheet. I need to have one of these from everyone if you want credit for being here today, so make sure you do that before you get started. Outside of that, complete the sheet, hand it in before you get to the computer work. Again, I need to give you some feedback so you have some sort of idea what you're doing right or wrong for graphing. Other than that, like I said, good luck, and let's knock this stuff out.